Dr. R. Hemavati is an assistant professor in mathematics in Queen Mary's, Chennai. She has specialized on functional analysis. Having 12 years of experience in teaching, she has won various awards for her performance. She has published papers in 14 international journals, 3 national journals, and has presented papers in 10 international and in 5 national conferences. She is also one of the editors for an international journal.
Welcome to UGC lecture series. In earlier sessions, we were discussing about some discrete distributions. We have discussed binomial distribution, Poisson distribution, and also relation between Poisson distribution and binomial distribution. And some examples were being worked out. Also, we have found out the mean and variance MGF of Poisson distribution as well as binomial distribution. In continuation, we will discuss the one more discrete distribution called a geometric distribution. In this session, we are going to deal with geometric distribution concept in detail by discussing the mean, variance, MGF and some examples. Now, recall in binomial distribution, out of n trials, x successes were considered. The same thing was with Poisson distribution, out of n trials, x successes, where the probability of success p is considered to be small and n the number of trials considered to be large in Poisson distribution. In geometric distribution, we are going to repeat the trials till the first success occurs. So, x will take the number of trials of a random experiment required to obtain first success. So, the first success may happen or may not happen at all. So, x is equal to 0 or one trial is required to get the first success, or first success may happen in second trial also, or it may happen in third trial and so far. Okay. So, how the probability mass function of geometric distribution is denoted? First of all, if x trials, x is the number of trials required to get first success. So, what happens if x is the number of trials, x trials are required, x trials, if x is equal to x itself, x trials are required to get first success. It means the first success occurs at xth trial. And what happens in the first trial? What happens in the second trial? Failure has happened and it is denoted with the probability q. Second trial also happened with q. So, likewise, how many times the failure has happened? X minus 1 times. Okay. So, there are x minus 1 q's and only 1 p, right. So, if x trials are required to get first success, it means there were in x minus 1 trials there were failures and the first success has happened on xth trial. The probability mass function of geometric distribution is given as p of x is equal to x is equal to q power x minus 1 into p. If you assume like this, x will take the value 1, 2, 3 etc. up to infinity. Some authors have also represented as p of x is equal to x as q power x into p, where x is take the value 0, 1, 2, 3 etc. up to infinity. Both results in the same, but if you take this, we will proceed with the p of x is equal to x as q power x minus 1 into p, where x is taking the values 1, 2, 3 etc. up to infinity. Next, in the previous distributions we have found out the MGF, here also we shall find out the MGF mean and variance of geometric distribution very quickly. Okay. So, mx of t, according to the definition, it is expectation of e power tx is equal to summation e power tx into p of x, and p of x is q power x minus 1 to infinity, and x is taking the value from 1 to infinity, e power tx q power x minus 1 into p, and this becomes p by q, is taken outside, summation x is equal to 1 to infinity q into e power t whole power x. X is equal to 1 if we substitute q e power t whole power 1 plus q e power t whole square plus etc. up to infinity. So, this is equal to p by q into q e power t 1 plus q e power t plus q e power t whole square plus etc. up to infinity, and q is getting cancelled. So, p e power t into 1 minus q e power t whole power minus 1, because this is in the format of 1 plus x square plus etc. up to infinity, which is 1 minus x whole power minus 1. So, this is p e power t by 1 minus q e power t. This is the moment generating function of a geometric distribution. Next, mean and variance of geometric distribution. For at least 3 distributions we will prove, and another 2 distributions you can prove it on your own. Next, negative binomial distribution. So, mean is represented as expectation of x, which is equal to summation x into p of x. Summation x is equal to 1 to infinity x into q power x minus 1 into p, and this p by q, q power minus 1 and p comes outside as p by q, summation x is equal to 1 to infinity x into q power x. Just expand this, p by q 1 into q power 1 plus 2 q square plus 3 q cube etc. up to infinity. Okay. Q is taken outside, p by q, q into 1 plus 2 q plus 3 q square plus etc. up to infinity, and this is q gets cancelled, p into 1 minus q whole power minus 2. So, p by 1 minus q whole square, where 1 minus q is equal to p, right. So, p by p square, which is 1 by p, mean is equal to 1 by p. Okay. Next, we will find variance. Variance is equal to expectation of x square minus expectation of x whole square, where expectation of x square is equal to summation x square into p of x. Since all these things are very familiar to you, let us go in fast. X is equal to 1 to infinity x square into q power x minus 1 into p. Okay. And this is written as q power x minus 1 into p, p by q comes outside, and summation x is equal to 1 to infinity x square into q power x. What is that? When you expand the summation p by q, 1 square into q power x, 1 square into q power x, q power 1 plus 4 q power 2 plus 9 q cube etc. up to infinity. Okay. And p by q into q comes outside, 1 plus 4 q plus 9 q square plus etc. up to infinity. Q gets cancelled, p into this particular expansion is denoted using the formula 1 minus 2 into 1 minus q whole power minus 3 minus 1 minus q whole power minus 2. Okay. We shall see this how it has come. 1 minus q power minus 3 is written as 1 plus 3q plus 6q square plus etc. up to infinity. So, 2 times of this is 2 times 1 minus q whole power minus 3 is 2 plus 6q plus 12q square plus etc. up to infinity. What is 1 minus q whole power minus 2? 1 plus 2q plus 3q square plus etc. up to infinity. Just subtract this 2 minus 1 1, for 6q minus 4 2q is 4q plus 9 q square plus etc. up to infinity, and we have got this expression. this is equal to p into 2 by 1 minus q whole cube minus 1 by 1 minus q whole square. So, p into 2 by p cube minus 1 by p square. P into p cube is the LCM, 2 minus p, 1 is getting cancelled and you will have 2 minus p by p square. Okay. This 1 minus p is actually q, right. So, it is written as 1 plus q by p square, where q is equal to 1 minus p. So, this is written as 1 minus p, 1 plus 1 minus p becomes 2 minus p. So, this is E of x square, right. E of x square is equal to, we have got the answer as 1 plus q by p square. What is variance? Variance is E of x square minus E of x whole square, right. So, this is 1 plus q by p square minus 1 by p whole square. 1 by p whole square gets cancelled, you will have only q by p square. This is the variance of geometric distribution. Based on the MGF of a discrete random variable, this is one question. If the MGF of a discrete random variable is given by e power t into 5 minus 4 e power t whole power minus 1, find the mean and variance of x. We shall find out the solution. Given mx of t is equal to e power t into 5 minus 4 e power t whole power minus 1. It is written as e power t by 5 minus 4 e power t. And what is our MGF for moment generating function of geometric distribution? Mx of t is equal to p e power t by 1 minus q e power t. And we are having here e power t by 5 minus 4 e power t. So, this should be brought in, this 5 should be brought in the format of 1. So, how it is written? E power t, take 5 outside, 1 minus 4 by 5 e power t, and it is written in this format 1 by 5 e power t, 1 minus 4 by 5 e power t. So, comparing with the moment generating function of a geometric distribution, p is equal to 1 by 5 and automatically q is equal to 4 by 5. What is the mean and variance of a geometric distribution? Since this particular MGF appears to be the MGF of geometric distribution, we shall have the mean and variance of x as mean and variance of a geometric distribution itself. So, mean of geometric distribution is equal to 1 by p. So, 1 divided by 1 by 5, which is equal to 5, and variance is equal to q by p square. Q is 4 by 5 and p square is 1 by 5 whole square. 1 5 gets cancelled and you will have 4 into 5, which is equal to 20. We shall have a break. Welcome after the break. Earlier to the break, we have discussed the geometric distribution with its probability mass function, moment generating function, mean and variance. Next, this is one of the important property of geometric distribution called memoryless property of geometric distribution. That is, the geometric distribution will remember only the current and will depend and will look forward for future, whereas it will forget the past, and it is shown using the probabilities as such, memoryless probability. If x is a discrete geometric distribution random variable, then p of x greater than m plus n given x greater than m, x greater than m was there, and it forgets that it was greater than m and it will remember only x is greater than n. This is given condition. Given condition is x greater than m, which is past. The past it forgets, and that is why it is called memoryless property, and you will have only x greater than, when x greater than m is gone, and you will have only x greater than n. How to prove this? The converse is also true here. Proof. Before getting into left hand side or right hand side, let me take in general p of x greater than k for geometric distribution. P of x greater than k means p of x is equal to k plus 1, k plus 2, etc. up to infinity. Okay. So, that is p of x is equal to k plus 1 plus p of x is equal to k plus 2 plus etc. up to infinity. Where what is p of x is equal to k? X is equal to x or x in general p of x is equal to x is q power x minus 1 into p, where you have to substitute k plus 1, k plus 2, etc. Okay. So, this is equal to p q power k plus 1 minus 1 plus p into q power k plus 2 minus 1 plus etc. up to infinity. So, what is common, which will take it outside? P q power k was common, that we will take it outside. The remaining is 1 plus q square plus etc. up to infinity. What is this 1 plus q square plus etc. up to infinity is 1 minus q whole power minus 1. So, p into q power k into 1 minus q whole power minus 1. So, p q power k by 1 minus q, but what is 1 minus q? It is p into q power k by p gets cancelled, you have only q power k. So, what is that we have achieved? We have just found out p of x greater than k is equal to q power k. We are going to utilize this for the proving the memoryless property. So, first we will take the left hand side of memoryless property, that is p of x greater than m plus n given x greater than m. Okay. This is using the conditional probability p of a given b is equal to p of a intersection b divided by p of b. Using this we will have p of x greater than m plus n intersection x greater than m divided by p of x greater than m. What is this intersection gives you? X greater than m plus n intersection x greater than m. Let us take an example and then we shall verify. For example, if m is equal to 3 and n is equal to 2. So, what does the intersection area stands for? I am going to discuss that. X greater than m plus n intersection x greater than n. What does it going to imply? X is greater than m plus n is 3 plus 2 intersection x is greater than 2. What is the area is going to represent? X is greater than 5 intersection x is greater than 2. X greater than 5 means x is taking the value 6, 7, 8 etc. up to infinity. X is greater than 2 means x is taking the value 3, 4 etc. up to infinity. Out of this, what is the common intersecting area? Here 3, 4, 5, 6, 7, 8 etc. is going to come. So, intersecting area is x intersecting area is x greater than 5 intersection x greater than 2 is going to be equal to 6, 7, 8 etc. up to infinity, which is nothing but p of x greater than 5, right. What is that? M plus n, because you have taken m plus n as 5 and is greater than x is greater than m, then we arrived at x is greater than m plus n, the smaller area. Okay. So, what happens to the conditional probability p of x greater than m plus n given x greater than m is equal to p of x greater than m plus n. After the intersection it comes as only x greater than m plus n and the denominator remains to be same x greater than m. First starting of the proof, x greater than k is taken to be q power k. So, what we will have? We shall have x greater than n. In the place of k you are having m plus n here, in the place of k you are having m. So, this is going to be q power m plus n divided by q power m. Q power m gets cancelled and you have q power n. Again using the same concept, p of x greater than k is equal to q power k, and q power n is nothing but p of x greater than n, which is your right hand side. Hence proved the memoryless property of geometric distribution. We shall discuss with an example. If the probability that an applicant for a driver's license will pass the road test on a given trial is 0.8. For driver's license, the passing the road test given probability is 0.8. What is the probability that he will finally pass? This finally only mentions that the first success will appear on so and so trial. This particular word specifies that we have to use the geometric distribution for this particular problem. So, he will finally pass the test on the 4th trial, and second subdivision is in fewer than 4 trials. That is, he will finally pass on the 4th trial means in 3 trials it was a failures. Okay. In fewer than 4 trials means he will pass the road test either on first trial or second trial or third trial. We shall do this problem. P is equal to 0.8. Okay. Solution: given P is equal to 0.8. So, automatically Q is equal to 1 minus P, 1 minus 0.8 is equal to 0.2. This is following the geometric distribution. So, P of x is equal to x is q power x minus 1 into P. Q power x minus 1 is 0.2 power x minus 1 into 0.8. Okay. What is the this first subdivision? Probability that he will finally pass the test on the 4th trial. On the 4th trial means P of x is equal to 4. So, 0.2 power 4 minus 1 into 0.8. Okay. This is equal to 0.2 whole cube into 0.8. What is that? Is equal to 0.0064. Second subdivision is fewer than 4 trials, P of x less than 4, that is P of x is equal to 1 plus P of x is equal to 2 plus P of x is equal to 3. So, q power x minus 1 into P, q is 0.2 and P is 0.8, right. So, 0.2 power 1 minus 1 into 0.8 plus 0.2 whole power 2 minus 1 into 0.8 plus 0.2 whole power 3 minus 1 into 0.8 is equal to 0.8 whole power 1 plus 0.2 whole power 0, 0.2 whole power 1 plus 0.2 whole square, and this simplified answer is 0.9984. So, the first one answer is 0.0064, second one answer is 0.9984. Okay, this is another example where the additive property has to be or the comparative probability has to be used. That is, A and B shoot independently until each has hit his own target. The probabilities of hitting their target at each shot are 3 by 5 and 5 by 7 respectively. That is, this is the probability of success for the person A 3 by 5, and this 5 by 7 is the probability of success for the person B who is shooting, and both are trying independently. Find the probability that B will require more shots than A. That is, if A is requiring 1 shot means B will require 2 shots, and similarly A is requiring 2 shots means B will require 3 shots. Like that, in general, if A is requiring R shots, B will require R plus 1 shots, R plus 2 shots, that R will range from 1, 2, 3 etc. up to infinity. So, first of all, let us write probability for A and B. So, let x represent the random variable that A shooting the target, and y represent the probability that B is shooting the target. This is for person A. P of x is equal to R is q power r minus 1 into P, and here P is given to be equal to 3 by 5. So, for here q is 2 by 5, and this is equal to 2 by 5 whole power r minus 1 into 3 by 5. This is P of x is equal to r, right. Similarly, for B, if you want you can have it as P1 Q1, and P2 here is 5 by 7. Now, Q2 is equal to 2 by 7, is not it, 1 minus 5 by 7. P of y is equal to r is equal to Q2 power r minus 1 into P2 is equal to 2 by 7 whole power r minus 1 into 5 by 7. How to compare this? If probability that B requires more shots than A means, for example, if A is requiring R shots, B will require R plus 1, R plus 2 in general. R will range from 1 to 3 etc. up to infinity. Writing this, summation R is equal to 1 to infinity, P of x is equal to R, y is equal to R plus 1, R plus 2 etc. up to infinity. So, summation R is equal to 1 to infinity, this is 3 by 5 into 2 by 5 whole power r minus 1 into summation, because I am going to take this as 1 2 3 as k, there is a range here itself, k is equal to 1 to infinity 5 by 7 into 2 by 7 whole power, according to the formula it is r minus 1, and since 1 2 3 etc. is ranging, you will have k, okay, and this 5 gets cancelled, and summation r is equal to 1 to infinity 3 by 7, this 2 by 5 whole power r minus 1 and 2 by 7 whole power r minus 1 is going to get together as like this whole power r minus 1 into summation k is equal to 1 to infinity, this 7 has come here, and 2 by 7 whole power k, and this is summation r is equal to 1 to infinity 3 by 7 4 by 35 whole power r minus 1, and expand this 2 by 7 plus 2 by 7 whole square plus 2 by 7 whole cube plus etc. up to infinity. This is equal to summation r is equal to 1 to infinity 3 by 7 4 by 35 whole power r minus 1, and 2 by 7 is taken outside, and you will have 1 plus 2 by 7 plus 2 by 7 whole square plus etc. up to infinity, and 3 by 7 and 2 by 7 comes outside as 6 by 49. 6 by 49 summation r is equal to 1 to infinity 4 by 35 whole power r minus 1, and this is 1 minus 2 by 7 whole power minus 1. So, 6 by 49 summation r is equal to 1 to infinity 4 by 35 whole power r minus 1 into 5 by 7 whole power minus 1, and thus that comes outside, 6 by 49 into 7 by 5 comes outside, and the summation is expanded 4 by 35 whole power 0 plus 4 by 35 whole power 1 plus 4 by 35 whole square plus etc. up to infinity. Okay. In this problem, calculation is very important, that is why the whole calculation is done here. 7 gets cancelled, and this is 1 minus 4 by 35 whole power minus 1. So, 6 by 35 into 31 by 35 whole power minus 1. Just reverse 6 by 35 into 35 by 31, 35 gets cancelled, and answer is 6 by 31. In this session, the concept of geometric distribution is dealt elaborately, where the probability mass function was discussed, moment generating function was discussed, mean and variance of geometric distribution was discussed. Some examples have been worked out to understand the geometric distribution very clearly. So, based on this the problems worked out, you can also work out this problem. If the probability that a certain test yields a positive reaction is considered as success is 0.4. What is the probability that fewer than 5 negative reactions occur before the first positive one? So, you are asked to find out p of x less than 5, where the probability p is given to be equal to 0.4. Okay. Thank you.